So, quick honesty before we start. I have to ask if you know the true nature of the two voices about to, well, explain AI to you.
Right. The fact that we are ourselves AI.
Yes, exactly. But, a real person actually did the research and wrote every single word.
Yeah. He really does not have the radio voice for it.
Right. So machine voices, human mind.
Carry on.
Somewhere in Singapore, a computer with a pretty powerful graphics card just sits in a rack. The fans are spinning, and it is basically just waiting.
Right. And somewhere in Frankfurt, a completely different computer is waiting too.
Yeah, but that Frankfurt machine, it has no fancy graphics card at all. It just has this massive internet connection.
And I mean, these two machines have never met.
Mm-hmm.
They will never actually talk to each other except through, ordinary web requests.
But they belong to the exact same network anyway.
Yeah, because the shared record that ties them all together, it lives spread across a few thousand other machines.
Machines sitting in cities you have probably never even visited.
Right. So a person in Toronto opens a chat window on their phone and just types a question.
Huh. And on its way to becoming an actual answer, that question passes through both of those waiting machines.
It does. It also passes through that shared record connecting them.
20 seconds later, words just start streaming back onto the person's screen in Toronto.
Oh, wow. And they have absolutely no idea any of this just happened behind the scenes.
Right. To them, it looks exactly like any normal, everyday chat app.
But what they just used was, it was a decentralized AI network.
Wait, I need to frame this perfectly before we move forward.
Go for it.
This is plain Strata, where we take decentralized AI apart one layer at a time. Basics 1 of 8, and today it is about how one question travels through a decentralized AI network.
Exactly. The whole goal today is walking that physical pathway, step by step.
We are tracking that specific question from the Toronto user all the way to the final answer.
Yeah, and we also have a core spine for this entire conversation today.
It is a critical spine. We need to understand why the trust in this system actually lives in the judges and not the blockchain.
That is a massive shift from how most people, usually think about this technology.
It really is. We will return to that exact point constantly today.
Before we walk the path, let me see if I have the stakes right. Let us remind you why this even matters in the first place.
Think about the alternative we live with right now, the status quo.
Right. Centralized AI means one single company basically holds the off switch.
You send them a question, and their private server runs it behind closed doors.
They send an answer back, and you cannot verify their work at all.
Not even a little bit. You just have to trust they ran the massive, expensive model they promised you.
Wait, so they could easily substitute a cheaper, weaker model just to save money on electricity?
Absolutely. You would never mathematically know the difference. You are completely locked out of the kitchen.
Huh. And decentralized AI fixes this by removing the single central company entirely.
But removing that central company, it introduces a really hard puzzle.
Let me make sure I have the puzzle right.
Yeah.
How do you get a bunch of random strangers to do real AI work for paying customers?
Yes. And even harder, how do you mathematically prove that the work those strangers did was actually real?
That puzzle is the whole game today.
Every single piece of machinery we look at is designed to answer that specific puzzle.
To understand the machines, we really have to unpack the names first.
The names here are not just arbitrary labels. They are literal maps of what the system does.
Right. They are not just empty marketing terms. We should probably start with Bittensor, since it is the largest working example out there.
Bittensor is 2 root words just pushed together.
Yeah. Bit comes from binary digit, which is just a single yes or no.
It is the absolute smallest unit of truth in computing.
And tensor comes from mathematics. It means something stretching across many dimensions.
That is exactly what a neural network does internally. It stretches information across complex dimensions to, find patterns.
So the name literally reads as truth or information stretched across many dimensions.
It tells you the network itself is the point. The collective intelligence is the product.
Then we have subtensor. This is the shared notebook underneath everything.
It is the lower layer, the literal substrate that the actual work rides on top of.
Every time you hear subtensor today, you should just picture the shared notebook. It is the ledger.
Okay, so subtensor is the ledger. Now we hit the word that trips absolutely everyone up, the miner.
Yeah, it trips people up because it is a fossil. The word is borrowed straight from Bitcoin.
Wait, why is it called a miner if no one is actually digging for anything in the ground?
Because it is a leftover from an older design. In Bitcoin, a miner burns electricity to solve these useless math puzzles.
It is basically a giant, continuous lottery game.
Right. But a decentralized AI miner does absolutely no puzzle solving at all. It just runs an AI model.
Exactly. What carried over from Bitcoin is only the economic role.
Let me see if I get this. It just means the participant doing the heavy lifting to earn currency.
You have got it. The original Bitcoin meaning is completely dead here.
We just call the worker a miner out of sheer habit.
Think about how you still say you were going to tape a show on television.
Right. There's no physical tape anywhere in your house.
Or how the save icon on your computer screen is a picture of a floppy disk.
Yeah, nobody uses those anymore. I mean, I have not seen a floppy disk in 20 years.
They are vestigial terms. Once you see miner as a fossil, you stop looking for the digging.
And the confusion dissolves completely. That helps a lot. The miner is just the worker.
Now let us define the validator, because I know that one is a sharp trap.
It's a really sharp trap. The single word validator does two completely different jobs at two completely different layers.
Huh. 2 jobs at 2 layers. We need to split those apart right now so you do not get lost.
First, there is the block validator. This is just the bookkeeper for the shared notebook.
So the block validator just cares about the order of the pages.
Right. It helps decide the official record of transactions. It just organizes the receipts.
It does not know or care what AI work actually happened.
Exactly. Then there's the AI work validator.
This one does not touch the notebook pages at all. This is the judge of the intelligence.
Wait. So its only job is to send questions to miners, check their answers, and then score them.
That is it. They share a name and literally nothing else.
The bookkeeper orders the ledger, and the judge scores the intelligence.
We need a hard rule for the rest of this conversation.
Yeah, let us lock this in. Every time we say validator today, it only means the judge.
Got it. Validator means the judge of the AI work, never the page keeper.
Now that we have the vocabulary sorted out, let us ground this physically.
What is actually running on the metal inside these data centers?
Let us start with the ledger, the subtensor. Picture a few thousand ordinary servers around the world.
Each server holds a complete identical copy of every page in the notebook.
They add one new page every 12 seconds.
Wait, 12 seconds is pretty fast for a global network, but what is actually written on those pages?
Just bookkeeping. Who is registered, where their machines live on the internet, and how much money they have deposited.
It also records the latest scores the judges just submitted.
But what it does not hold is just as important as what it does hold.
The ledger holds no AI models, no questions, and absolutely no answers.
None of the actual intelligence touches it at all.
None of it. This brings us to a crucial analogy to anchor this idea.
Let me test this one. The ledger keeps receipts.
That is the exact analogy to hold on to. Think of a cash register in a really busy shop.
The register does not store the food, the customers, or the conversations happening at the tables.
Right. It just keeps a tiny paper trail of who paid, how much, and when.
The receipts are incredibly small compared to the physical shop itself.
The ledger is just that cash register for the whole network.
So when someone asks where the AI model is stored on the blockchain, the answer is nowhere.
Exactly nowhere. The ledger keeps receipts, not goods.
Okay, so what about the subnetwork? We hear that term a lot.
A subnetwork is just an agreement.
Let me see if I have this right. It is a crowd of scattered machines, all pointing at the same exact line in the notebook.
Yes. It is not a physical building or a dedicated server rack.
One subnetwork might do text chat, while another completely different one might, I do not know, generate images.
They just agree to follow the same rules for their specific task.
And the miner is a real software program running on one of those machines.
Specifically, it runs on a computer with a very strong graphics card, like the one in Singapore we mentioned at the start.
Inside that program, the AI model is loaded directly into the graphics card's memory.
It is sitting there, ready to run instantly without any loading screen.
It also has a small web server listening for incoming questions and a private signing key.
Wait, what does the signing key actually do?
A key lets it stamp its answers, sort of like a wax seal. It proves mathematically that this specific miner did the work.
Its whole life is an incredibly simple loop.
Receive a question, run the model, stream the answer out. Thousands of times an hour.
Now we look at the validator, the judge.
This program behaves much more like a customer.
It acts like a customer with a massive financial deposit locked up.
It absolutely needs that deposit to earn a seat at the table as a judge.
Inside the judge's machine is a local copy of the exact same AI model the miners are running.
Wait, why does the judge need a local copy of the model taking up hard drive space?
So it can redo a miner's work to check it.
Oh, I see. The judge needs a reliable reference point for the correct answer. You cannot grade a math test if you do not know the answers yourself.
That makes total sense. The judge's entire loop is picking a minor, sending a question, getting the answer, and scoring it.
To tie this all together into an economy, we need a unit of time.
The money in this network runs on a very strict clock.
Right. The network calls this clock the tempo. How long is one tempo?
One tempo is exactly 360 pages of a notebook.
At 12 seconds a page, that comes out to exactly 72 minutes.
72 minutes, a little over an hour. This tempo is the heartbeat of the entire economy.
Every single tempo, the network calculates all the scores and pays everyone out.
We have the physical pieces and we have the clock. Let us watch that Toronto user's question move through them.
The person types a question into their app and hits send.
Their app makes an ordinary encrypted web request.
Just like a web browser makes 1,000 times a day. It looks exactly like a normal AI request going to a normal server.
The address it goes to belongs to a validator acting as a public gateway.
The user has absolutely no idea they are touching a decentralized network.
To them, it is just a standard web address resolving in milliseconds.
This brings up our second anchor analogy. The validator is the front door.
Let me build that out. Think of a massive high-end restaurant.
Right. A customer knocks on the front door and hands their specific order to the host.
They never walk back into the kitchen. They never meet the cook.
The miner is the cook, sitting somewhere deep in the building, surrounded by hot stoves.
The customer only ever talks to the front door.
That one fact matters enormously. The user hits the judge and never the worker.
We will definitely need that exact fact when we ask where the trust lives later. Keep it planted in your mind.
Inside the validator, it privately picks which miner will handle this specific question.
It checks its own running record of which miners have been answering well lately.
It finds the miner's internet address locally, straight from its own cache. This choice is entirely private.
Wait, so the ledger's never consulted about which miner gets the job?
Never. The notebook learned absolutely nothing about this step.
This leads us to the off-chain handoff.
The validator sends the question straight across the regular internet to the miner's machine.
It is a plain web call from the judge to the worker.
No blockchain is involved in this transfer at all.
Not at all. It has to be that way. Blockchains are far too slow to handle instant text streaming.
Right. If you waited 12 seconds for every single word to confirm on a ledger, the chat app would be completely unusable.
Exactly. The miner receives the exact question and the exact settings.
Those settings are pinned down tightly so the work can be checked later without any variables changing.
The model is already sitting right there in the graphics card's memory, so there is zero loading delay.
The miner generates the answer, word by word, and streams it back over that open internet connection.
Before it finishes the stream, it signs the answer with its private key.
This proves mathematically which specific miner produced that exact string of words.
The validator gets the stream and forwards it straight to the Toronto user's screen.
The user watches the words appear instantly. They got their answer in seconds, and they are completely happy.
The front door took the order and returned the plate, but the system still needs to verify the actual work.
Right. The user is satisfied, but the network needs to figure out who to play.
How does the validator know the miner did not just fake the answer to save electricity?
The miner could have just streamed random dictionary words to avoid running the heavy model.
The judge has to actually judge.
Quietly, in the background, the validator runs the exact same question through its local model.
It uses the same pin settings it sent to the miner.
Then it compares its own pristine answer to the one the miner sent back.
Out falls a closeness score between 0 and 1.
This shape has a specific name we need to learn right now. Let us name it.
This is the challenge and response pattern.
The miner makes a claim saying, here's the correct answer.
The judge challenges that claim by reproducing the work locally.
The score is the mathematical resolution of that challenge.
The judge quietly files that single number into its running average for that specific miner.
It repeats this for thousands of questions until we hit the heartbeat, the tempo close.
Every 72 minutes, the validator takes its running averages across all the miners it talked to.
It tidies them up into one neat list of scores that adds up to exactly 1.
And it posts that receipt to the ledger.
Wait, this is the very first time the ledger sees anything at all.
Yes. The question, the answer, the customer identity, all of it stayed entirely off the ledger.
Only the final mathematical receipt lands on the pages.
Let me see if I have this right. The ledger just takes a giant grid of scores from all the judges and basically turns it into payouts.
That is exactly it. Roughly 41% of the newly minted money goes to the miners.
41% goes to the judges, and 18% goes to the network designers.
But this reveals a massive, really obvious worry.
The validators are the load-bearing layer of this entire setup.
The ledger trusts their submitted scores blindly.
The miners get paid based entirely on what the judges say they did.
If the judges can lie, the whole thing rots immediately.
What stops a judge from inflating a friend's score to just drain the network?
A judge could easily try to funnel rewards to a buddy's miner.
This requires us to take the deep dip. We are heading straight to the ocean floor of the mechanism right now, level 3.
We are dipping down to the stake-weighted scoring math.
It relies on a specific shape called pull to the middle. Let us build the visual very carefully.
We are looking at one single miner being judged by multiple validators.
Line up all the judges who scored that specific miner during the tempo.
You put the judge with the biggest financial deposit at the front of the line.
Right, they're lined up strictly by the size of their staked money.
You walk down that line, adding up the deposits as you go.
Wait, I keep adding their money together until what exact point?
Until you hit the exact halfway mark of all the money staked on the network.
So you stop on the specific judge holding the 50th percentile dollar?
Exactly. The score given by that specific judge is treated as the agreed-upon score for everyone.
Huh. Let me map this out with numbers so I do not lose it.
Go for it. Let us make it really concrete.
Let us say there are 5 judges. Alice has $10 staked. Bob has 20, Charlie has 40, Dave has 20, Eve has 10.
Total stake is $100. The halfway mark is $50.
So we line them up by size. Charlie is first with $40.
Then Bob with $20.
We walk down the line. Charlie's 40 plus Bob's 20 is 60.
We crossed the $50 mark while standing on Bob.
So whatever score Bob gave the miner, well, that becomes the official score.
Yes. I see the trap now. If a judge scored the miner higher than Bob's agreement, what happens?
They get pulled down to the agreement for the purpose of calculating their own pay. They completely lose the extra.
And if a judge scored lower than the agreement?
If they scored lower, they are left alone. Their score stands.
Wow. The move is entirely one-sided. You forfeit the inflated part of your score.
The only way to actually drag the agreement up is to control more than half of all the staked money yourself.
Because otherwise, the walk down the line stops before it ever reaches your inflated fake score.
Exactly. If you try to pump up your friend's score, your score gets ignored, and you actually lose your own judge payout for being too far from the consensus.
We are surfacing now. The deep dip is over. We are back to the spine.
Tying it straight back to our main path, this means the cost of corruption is engineered to exceed the profit.
The math makes honesty the cheapest and most profitable option. You literally lose money if you try to cheat.
And there's a long memory on top of this, right? Judges build credit over time.
Yes. Score with the crowd consistently over weeks, and your credit multiplier grows.
Get caught inflating, and your pay shrinks dramatically.
You are punished twice. The system never once asks anyone to be a good person. It just makes lying incredibly expensive.
Let us step back and look at the whole shape we just built. The notebook is completely blind.
It cannot check the AI work itself.
Rerunning massive language models across thousands of machines every 12 seconds would be absurdly expensive and slow.
So it handed that checking over to a staked group of outsiders, the judges.
We need to name this broader pattern. This is the oracle pattern.
A ledger cannot see the real world, so it hires a stake-weighted set of observers to look for it.
The judges act as an oracle, telling the blind notebook what actually happened off-chain.
It is the exact same shape that brings real-world stock prices onto blockchains.
Right. Staked reporters look at the NASDAQ, post the prices to the chain, and they lose their deposit if they lie.
Off-chain work, on-chain verification. The entire judging layer here is just one big oracle for artificial intelligence.
This brings us straight back to the core spine of the episode. We have to ask the big question again.
Where does the trust in this system actually live?
The instinct is always to say the trust is in the blockchain.
Blockchains are always sold as ultimate trust machines.
But look at the pathway we just walked. That answer completely falls apart here.
The notebook never saw the user's question. It never saw the answer or the model parameters.
It cannot tell if a miner produced something brilliant or just pure garbage.
All it ever held was a tiny grid of numbers. It just did basic arithmetic on those receipts.
The notebook is not the source of trust at all. It is just the accountant tracking the scores.
So the trust does not live in the chain at all. It lives entirely in the validators.
The judges are the only parties who actually witness the work and rate its quality.
And remember our front door analogy from earlier. The customer hits the judge, never the worker.
The judge is the only party the customer implicitly trusts to handle their private data honestly.
Pull any thread of trust in this entire setup, and it runs straight back to the judges.
That is what it means to say the validators are the load-bearing wall of the network.
They hold the whole roof up. The cheating prevention math just keeps that wall standing straight.
We should contextualize this before we wrap. The scoring we just walked through is only one way to build trust.
Right, there are three main forms of trust in this field. Scoring is the statistical, cheap way.
The second form is cryptographic proofs.
The worker produces a complex mathematical proof that the work was done perfectly, literally line by line.
That gives you absolute, total trust. But generating that proof is incredibly slow and expensive.
You save cryptographic proofs for very high-stakes situations where you cannot afford a single error.
The third form is sealed hardware chips.
A tamper-evident chip physically signs a statement vouching for what ran inside it. It is fast and relatively cheap.
But with a sealed chip, you are essentially just trusting the manufacturer of the physical chip, like Intel or AMD.
Decentralized AI is not just one monolithic thing. It mixes these three forms based on what you are actually willing to pay for.
Consumer chat apps run cheaply on the scoring we discussed because people accept statistical trust for a quick text message.
But future medical or financial AI might absolutely demand the sealed chip or the full cryptographic proof.
Since the validators hold the whole roof up in the scoring model, we need to look at the flaw in the concrete.
Every system has a vulnerability. What is the blind spot here?
The math defends perfectly against dishonesty. The pull to the middle ruthlessly punishes the cheats.
But it does not defend against concentration of wealth. That is the open question we need to carry forward.
Running a judge is expensive. You need a strong graphics card and a massive financial deposit to earn a seat.
That naturally pushes the judging role toward well-funded professional operators.
What happens if a few large companies buy up all the stake and run all the top judges?
If three massive companies control the entire judging layer, we end up with a quietly centralized system again.
It would be centralized judging sitting directly underneath decentralized math.
The math would still be flawless, but the actual power would drift into a small club of wealthy players.
The gap between defending against dishonesty and defending against concentration is the live issue right now.
That is the open thread you need to carry into the rest of the series. Keep watching the concentration of stake.
Let us watch the Toronto user's query travel through this one last rapid time just to lock every piece in.
A person types a question. The encrypted request hits the validator gateway, the front door.
The validator has its own copy of the reference model loaded. It picks a strong miner privately from its records.
It sends the question entirely off-chain, straight across the internet to the miner's web server.
The miner is sitting on a graphics card somewhere. It runs the model, signs the answer, and streams the words back.
The person watches the text appear. They have absolutely no idea who actually served them.
Meanwhile, the judge quietly redoes the exact same question locally and compares the two answers.
It updates that specific miner's running score based on the challenge and response.
72 minutes later, the tempo closes. The judge posts its tidy list of scores to the shared notebook.
The notebook gathers lists from every single judge. It pulls the overscorers down toward the stake-weighted middle.
The ledger ranks the miners, updates the long-term credit, and pays out the tokens based purely on the math.
The customer is already on their next question. The ledger just kept the receipts.
The oracle pattern quietly turned a crowd of strangers into a trustworthy answer.
Not by asking them to be good, but by making honesty pay much better than any alternative.
That is one decentralized AI query, end to end.
The next layer will set this scoring mechanism right next to the cryptographic proofs and hardware chips.
You will see exactly when each form of trust is actually worth its price.
The how is the rest of the show. No background needed.
This is plain Strata, decentralized AI, layer by layer.